Okay, guys, I want to review all things linear, our linear function unit. And in this unit, we're going to break it down into a few parts. The first part, we're going to start with graphs and equations of linear functions. So let's just remember that the way we can represent functions is in a table, a graph, or an equation. And for our functions that are linear, remember they have a constant rate of change called slope, and we use the variable m to represent slope. The idea is rise over run to get from point to point. So we're going to go, if it's positive, we're going to go up and then to the right. If it's negative, we're going to go down and to the right. The rise is our vertical change compared to our horizontal change. So rise is the vertical, so rise is the y's, and the run is the horizontal change, the x values. For our formula, we're going to use y2 minus y1 over x2 minus x1, where the subscripts 1 and 2 are just your ordered pairs. And remember, an ordered pair is written x, y, x, y, just like the alphabet, x, y, z. So the x is your horizontal values and y are your verticals. So here is a positive slope. We're going uphill. We have a negative line going down. When we have a slope of 0, that is the horizontal line that runs left to right. And our undefined slope, which is our line that is not a function, is the vertical line. Here are the three types of linear equations: slope-intercept form, y equals mx plus b. This is very useful for graphing because we have a starting point, the y-intercept, which is 0, comma, and then whatever the y-intercept value is, and then our slope, rise over run. Point slope is useful when we do not have the y-intercept ordered pair, and we can use the slope and then one of the points to plug in, and we can find the y-intercept and write our equation in slope-intercept form. Then we have standard form, and this is where your x and y is on one side and your constant is on the other. Remember, the coefficients of x and y, your a and b, must be integers. Julie has $650 to spend on books for college. Each book costs $130. We're going to write a linear equation to represent her book budget. So she starts out at $650, and then each time she buys a book, her budget goes down. So her constant rate of change is negative 130 times x, and she starts out with $650. The x value is each book, and the y value is total money that she has. Because at 0 book, she has $650. So that tells us that y is total money she has. It is not total money she has spent. So let's go ahead and see how many books she can buy. So the most amount of books that she can buy is when y is 0. So we're going to plug in 0 for y because 0 is total money she has. So when she has 0 money, we'll be able to see what x is, how many books that she can buy. So we're going to isolate x and subtract out the 650. This leaves us with negative 650 equals negative 130 times x, divide by negative 130, and x, books, is going to be 5. So let's look at our domain and range, but let's graph our function first. So at 0 books, she has $650. When she has 0 money, she can buy 5 books. Now we have the y-intercept and the x, and we can simply just draw our straight line as best we can. Now, let's identify our domain, which are the x values. So the least amount of books is 0. The most amount of books is 5. The least amount of money she's going to have is 0, and the most amount of money she has is 650. So domain are your x values and range are your y values. Now, I want to make sure that you understand that when you are given a function table, the way we can tell if it's linear or not is if it has a constant rate of change. So x was books, and our output was money that she has. So we're going to do these in order from least to greatest. So 0 books, 1, 2, 3, 4. And at 0 books, she had $650. And then each time it's going to go down by 130. We get 520. And then when she buys another book, we have 390. And then when she buys a third book, she has $260 left. And then when she buys a fourth book, she has 130. So when you're given a function table, if you were given this and you were asked, is this linear? You need to compare the change of the y's of each set to the change of the x's. So we can see from 650 to 520 is going down 130. From 0 to 1 is a change of 1, so we have negative 130 over 1. From 520 to 390, we went down 130. And from 1 to 2, we went down 1. From 390 to 260 is a difference. We get negative 130. And from 2 to 3 is 1. And from 260 to 130, we went down 130. And then from 3 to 4 is a change of 1. So as you can see, all of these rates of change are the same. They are constant. This is what it means to be linear. Now let's take a look at our second application problem. Mac charges $50 for a diagnostic test of $20 each hour he works on a vehicle. We're going to write an equation to represent his billing fee. We're also going to say that Bruce is going to bring his truck to Mac to get fixed, but the maximum amount of money he has is $250. But for the equation, we only need the diagnostic, the initial value that Mac charges, and then we need to know his constant rate of change, his hourly charge. So our X is hours that he works on a vehicle, and our Y is his total charge or the total cost. So let's graph this. So Bruce is going to pay $50 up front, and now we need to know what is the maximum amount of hours that Mac is going to charge. So we want to know, so we're going to plug in 250 because that's how much money, that's total cost, that's how much his total money that Bruce has, and then we are going to solve. So Mac can work on his truck for 10 hours. So this would be right here. So at 10 hours, and we can connect these. So let's look at our domain. So domain is hours. So the least amount of hours that Mac will work on Bruce's truck is 0. The most is going to be 10. When he brings his truck, he gets it tested. So the least amount he has to pay is 50 for 0 hours. And then if he does have his truck fixed, the most amount of money that he will pay is 250. Okay, now let's just take a look at some graphs and remember how to graph these. And remember, they need to be in slope-intercept form, which is y equals mx plus b. And in these two examples, they are. So we're going to just simply start and graph. Our y-intercept is 5, so 0, 5. Okay, 0, 5 is the y-intercept. Then our slope is going down 3, because we have a negative here. We're going to go down 3, 1, 2, 3, and to the right, 1, 2. Down 1, 2, 3, to the right, 1, 2. We could also try to go in reverse. So you go back to your initial value, and instead of down and right, we're going to go up and left. So we can go up 1, 2, 1, 2, 3, and to the left, 2. And see how it lines up and makes that nice linear function. Okay, our second example, it is in slope-intercept form. We're going to start at -6. Our slope is positive. It is going up 2 and to the right 3. So we're going to go up 1, 2, to the right, 1, 2, 3. Up 2, right, 1, 2, 3. and draw a line all the way through with arrows on the end. Okay, in this example, our equation 4x minus y equals 5 is not in slope-intercept form. So we are going to solve for y and make it look like y equals mx plus b. So we're solving for y. So we're going to subtract 4x from both sides. We're going to bring down negative 1y equals, I'm going to put my linear term first and then the constant. We're now going to divide each term by the negative 1, and we have y equals 4x minus 5. So our starting point is going to be 0, negative 5. And our slope is up 1, 2, 3, 4 to the right 1. Up 1, 2, 3, 4 to the right 1, and so on. That is not perfect, but you get the idea. Okay, let's solve one more time. We want to isolate the y, so we have y equals mx plus b. Let's add 6x to both sides. We're going to bring down negative 9 times y equals 6x minus 18. We're going to divide each term by the negative 9. Y equals a positive over a negative. I'm going to bring the negative to the top, and this simplifies by a factor of 3. Negative divided by negative is positive. So we're going to start at 0, 2, and our slope is down 2, right 3. Down 2, right 3. Or we could go up 1, 2, and left 1, 2, 3. Okay, let's remember the two special lines. We have the horizontal and vertical line. This is x equals 4, so that means that our line must go through the x-axis at 4, and it is the vertical line, which has a slope that we identify as undefined. It is not a function. Then we have y equals negative 3, so the line must pass through negative 3 on the y. So this means it is the horizontal line with a slope of 0. Okay, now given a graph, let's identify the slope and the y-intercept. So our slope is going up 1 and to the right 1, 2, 3, 4, 5. So we have a slope of 1 over 5, and we have a y-intercept of 0, 1. So our equation is going to be y equals 1 over 5x plus 1. Okay, let's take a look at another graph. Okay, this time we have a negative slope because it's sloping downhill. So just find any 2 points you can. Here's a nice point that crosses right at the corner of the grid. So we're going to go down 1, 2, 3, 4. So that's negative 4, and to the right 1, 2, 3. So we have a slope of negative 4 over 3, and it passes through at 0, negative 4. So negative 4 over 3 is our slope. And then the y-intercept 0, negative 4. So we put that out together, y equals negative 4 over 3x minus 4. Okay, on this graph, we can see it has a slope of 0 and it passes through 0, 2. So we don't need to say y equals 0 times x because then that's nothing. And so we have y equals 2. On this graph, our line is the vertical line, which is not a function. So we're going to say that the slope is undefined. And I'm just going to use the null symbol to represent there is no y-intercept. It does not pass through the y-axis at all. So it passes through x equals negative 6. Okay, now we're going to write a line that passes through the two given points in slope-intercept form. Now, notice that we have been given the y-intercept. So our b value is going to be 8. We're going to find the slope. So slope is going to be 8 minus 3 over 0 minus negative 4. This gives us 5 over 4. So we have y equals slope of 5 over 4x plus 8. Now it says determine if -8, -2 lies on this line. So we plug it in to see what kind of statement. So for y, I'm going to replace it with -2. For x, we're going to replace it with -8. Bring down the -2. 4 goes into -8 -2 times. -2 times 5 is -10 plus 8. So we get -2 equals -2. That is true. So yes, this point is part of this line. Write the line that passes through these 2 points. This time we do not have the y-intercept, so the first thing we have to do is find slope. So y2 minus y1 over x2 minus x1. I like to do keep, change, change. This gives us 4, and this gives us 16. We have a slope of 1/4. Now, I taught you a new way instead of using point slope, but if you do use point slope, it's going to look like this. If I'm going to use the first ordered pair to be my point for point slope, we will have y minus y1, which is -6, equals the slope. That's supposed to be 1/4. X minus -4. And then we would distribute and solve for y. Which this is an easy way as well. So this works every time. So the y-intercept would be 0, -5. Now let me show you the other way. If you don't want to use point slope, we have y equals 1/4 x plus b. So this is slope-intercept form. Once we get here, we don't know the b, so we can choose any point to plug in for x and y. So it is very similar to point slope. So I'm just still going to use the first point. So I'm going to plug in -6 for y. I'm going to plug in -4 for x. So you see, we end up doing the same process, just in a little bit different order. So altogether, y equals 1/4 x minus 5. It says determine if -8, 7 lies on this line. So we're going to plug in 7 for y, -8 for x. 4 goes into -8, -2 times. -2 times 1 is -2 minus 5. I get 7 equals -7. This is false, so no, this point is not part of that line. Okay, let's convert this to standard form, so they're in slope-intercept form. So we need to get this x term on the left side, so we simply subtract out 3x. This is both the -3 and 1 are integers, so we're good to go. The only thing is sometimes they may want this leading coefficient to be positive, so I can multiply through by -1, and it just changes every term to its opposite sign. So both of these are correct. Okay, in this one, we can move our term to the left first, or we can multiply through by 3 to get rid of the denominator. It does not matter. Those 2 steps is up to you, whichever you prefer to do. So I'm just going to move my fraction over. And now I need to make this 2/3 an integer. So we're going to multiply through by the least common multiple of 3. So we distribute 3 to each term. So when I distribute to 2/3, the 3's cancel, leaving me with 2x plus 3 times y equals 3 times 1. And now these are both integers.